Okay, so let's look at how those big RGB panels are made, at least the ones with Raspberry Pi and a Henry's library that supports 3 channels. So this fantastic board here takes one Raspberry Pi and gives you 3 channel outputs. And as you can see, 1, 2, and 3, which is why you have 3 panels, 3 rows of panels going down of 9 panels. So 3 times 9 is 27. So that's for the wiring, and that allows you to refresh more quickly and push more pixels with more refresh rate, and less flickering visible. Now, how this is put together. First, I have to thank Mark for those laser cut pieces. You can see the holes don't quite necessarily align. I had to use a soldering iron to move some of those holes a little bit, because we have those panels with blue labels, P5, and we have those panels with pink labels, also P5. And guess what? The holes are not in the same place. Almost, but not quite, because of course it would be too simple. And then, well, at least this pink panel and that pink panel, they're aligned, everything looks the same. And the label is almost the same, because they're not made the same time. Let's see, like 3264, 16 less and 5. Looks about the same here. Actually, no, it doesn't. And well, sure enough, they're not the same either. Those are the newer panels. They're actually good. And these are the old ones that were wired wrong from the factory, and the colors are reversed. So when you say, can I have blue? It will be, oh, sure, here's some red for you. I want to be clear, there's labels here of what color is which, right? The labels are correct, but underneath it's wired wrong, because, it would be too simple if they just did right or check at the factory before shipping to customers. So I have code that looks at which panel's been displayed. If it's 1, 2, 3 on each chain, it swaps the colors. Yay, I have to write that, of course. Now, the ribbon cables, you can notice that I'm using short ribbon cables. They want the ship width, and that they're opposite. Also, if you pay attention, you'll see every other panel is upside down. And that's actually by design. Allows you to use those short ribbon cables as opposed to going sideways for longer cables. It is actually good because of the bus length. Those cables are too long. Eventually, the clock doesn't get there on time, and it causes issues. And of course, it saves a bit on cabling too. But yeah, it means that every panel is reversed, every other panel is reversed, so that's more code to take the frame buffer and reverse all the pixels before display. And that was not fun code to write, but I wrote it, and it's worth it for cabling. So I have custom code to fix colors in the middle, and then custom code to reverse panels. As for power, I have this big power supply here, 60 amps, way too big, but I like it because it doesn't make any noise. I had a smaller one, and it would start making noises if I took too much power from it, which I didn't like. I just found this nice little power distributors, just plug everything nicely. Some holes actually just aligned with one hole, so I can have it not flop around too much. Here I have a second distributor that finds like some hole here. It's not perfect, but enough. And then this one is linked back to the main power supply. Because those cables are not infinite length, so there's 2 middles, I guess. And I try to use a set wire to power the Raspberry Pi, and it kind of works, but I think at some point the power bit can reboot. So I'm going to do some more testing. If it's true, I'm going to have to power the Raspberry Pi using USB-C independently from this power supply. It would be a shame, but we'll see. Anyway, this is how the sausage is made.